Okay, it's clear that the approach using virtual pooling works well. But let's for a minute turn to what we would do if we didn't have DataSHIELD available. And perhaps the most common approach to doing this would be to do a study level meta-analysis, or SLMA, by correspondence. Under this approach, which is used widely, particularly amongst genomic consortia, the analysis center, which would then be an administrative unit rather than a co-computer, as in the case of DataSHIELD, that analysis center would request each study to fit the model or models that are needed for the analysis that's required. And it's these models that are then to be pulled. Now, this request will have to be sent administratively, for example, by email or phone. Having fit the models, each study then will return its estimated regression coefficients and standard errors to the analysis center, again administratively by email or phone. The analysis center will then combine estimates of the coefficients and their standard errors across study using random effects or fixed effects meta-analysis. Now, this approach works fine, but a problem fairly regularly arises. So imagine a genome-wide association analysis with 1 million genetic variants. You do the analysis and 1,000 significant hits arise. Now, an obvious thing to do is to look for interactions between those 1,000 hits and a variable, for example, sex. However, unless models including those interactions have been part of the original list of models the studies have been asked to fit, we must now request them to fit them at this stage rather than previously. Because this must be organized administratively, this could take days or even weeks. And crucially, this same process will have to be followed every time further analytic exploration is deemed as being useful. Now, crucially, DataSHIELD can fit precisely the same set of models and do precisely that same set of work, but it can be carried out with central coordination of the whole process by the computer AC, and critically, all can be taken in real time.